Assalamu alaikum viewers. I'm Mohammad Asad Khan and this is your Excel lesson 24 project cost benefit analysis NPV IRR BC ratio, and we are basically right now discussing part 1 of this session, and there's also a part 2 of this session. So I hope this lesson finds you well and in best of your health, and kindly go through the session till the end to have a good grip of it, and going to the sheet. And again, the way I always says that the sheet on which I work, the data sheet, is available in the description, so you can download it and practice on it, and practice makes us perfect. So going on the data sheet again, the way I always start, your boss come up to you and says that, hey, one of my colleague, one of my business friend has an option to invest. So I have like, the company has like 98 million or so with us, and we have an option to invest into a project, or we can go to the bank and invest into the bank. So you may come up with the proposal, with the idea, where should we invest, in the project or into the bank. So you simply tell your boss that, boss, I will substantiate my argument so that you can go into the board and you can convince the board on those grounds. But please, this time I need some time from you, and I will convince you in two parts, part one and part two. Part one, I will give you the three options on IRR, the NPV, and the BC ratio of this project. And in part two, I will give you the different scenarios. Discussing the part one, first, I would like you to basically know what are these three concepts: the NPV, net present value, the internal rate of return, and the BC ratio. These are three different concepts, but closely associated with each other. And whenever we talk about project benefit cost analysis, we basically discuss these three concepts together. So this is the concept of cost benefits and their comparison. To determine first, to determine the viability of a project, the costs are compared with the benefits. That is, if the benefits are greater than cost, project is considered viable. That is very simple. You can simply compare it with your life. Like if you invest in your child, and if you invest in the education of the child, you always sees the future, that in future what he or she will become. So you basically choose the right school, the right education as per his aptitude, and then you go for it. And again, when the child goes to college, then he or she decides what he or she wants to do to become a professional and to earn the best. So this is the first thing, and this is the second point: is the proper identification of cost and benefit is therefore a step of basic importance. So you need to know your costs beforehand, and what would be the benefits beforehand, before going into the project cost benefit analysis. Third thing is, in project appraisal, the project objectives provide the basis of costs and benefits. For public sector projects, the objectives can be as specific as provision of municipal services to citizens of a project, to sometimes as broad as to maximize the national income or reduce poverty or stimulate economic growth. And in, of course, corporate side, it's the profit, how much profit the project can gain. So the fourth point is, the all projects consume resources such as land, labor, capital, machinery, etc. Here from capital, we mean basically the financial capital, and machinery, etc., and produce outputs in the form of goods and services. Whereas the consumption of resources through investment is, in project, is a cost to the economy. The above four lines, which I have three lines which I have discussed, are basically the costs. the addition to the goods and services is the benefit. Finally, what comes up as products or services is basically benefit to the economy. So there are two analysis with and without versus before and after. Before and after, we also call it ex ante or ex post. So here, the first point is while appraising a project, an analyst attempts to identify and value the costs and benefits that will arise with the proposed project and compare them to the situation that will prevail without the project. It's very simple. Without the project, what could have been there, and with the project, what is there. So that is the comparison of with and without. The difference between these two situations is the incremental net benefits arising from the proposed project. Therefore, to identify the contribution of a project, the correct approach is to compare the with and without situation with the without project situation. With project situation, without the project situation. Very simple. I think it's not, there is not much to explain on it. The third one is it is inappropriate to compare the situation before and after the project because such a comparison fails to account for changes happening irrespective of the project. Because you know this all these this analysis, this benefit cost analysis is basically before starting the project, and before and after means you are basically comparing it after the closure of the project. So that would not be appropriate at this stage when you are basically doing the project analysis before the start of project, and you want to propose your boss before the start of project, and you are comparing the project. So before and after analysis would be good after the closure of the project for lessons learned, but not at this stage. So classification of cost and benefits. In cost, there are direct costs, like costs are directly borne by the project and also known as primary cost. The component of direct costs are expenditure incurred on all goods and services used in execution of a project, including taxes, import duties, subsidies, etc. However, these components are treated differently in financial and economic analysis. Indirect costs, the project may lead to cost benefit incurred outside the project itself. Such a cost is known as indirect or secondary cost. For example, construction of dam may reduce river flow, causing an increase in the cost of dredging of the dam site. If such a technological externality is significant and is so be identified and valued, it may be treated as an indirect cost to the project. And there are tangible costs. The costs that can be monetized are known as tangible cost, and these may include component of direct and indirect cost. Simply on the cost which you can basically find the value, that is the tangible cost. And intangible cost, these costs cannot easily be monetized as intangible costs. The damage caused to the human health by air, water, and noise pollution gives examples of intangible costs, though we are basically coming towards it. The world is coming towards it, and we are now with the extreme weather, pollution, and damage to the environment. We are also knowing the cost to these, but still there is a long way to go to find the monetize the cost of such negative externalities. Similarly, benefits, direct benefits, directly or primary benefits are those benefits that are directly flow from the project. Indirect benefits are the benefits that occur outside the project are considered secondary benefits in contrast to the primary benefits which occur to the project itself and are also derived as direct benefits. Secondary benefits are also known as indirect benefits. Tangible benefits, all the direct and indirect benefits that can be measured in money terms are known as tangible benefits. And the last one, intangible benefits and positive externalities. Intangible benefits refer to the benefits that cannot be measured in monetary terms or money terms. Examples of intangible benefits are improvement of a site as a result of construction of a dam and appreciation in value of real estate due to infrastructure development. So next, financial and economic appraisal. Now we are mainly coming towards point. Previously we were discussing the basically the concepts to clear the concepts. So now for financial appraisal, the financial soundness of the project must be assessed the way your boss has said. This should include the incremental financial benefits and costs to the project and the IRR or NPV, internal rate of return on net present value. Assumptions underlying the forecast of financial benefits and cost, for example, market outlook for key outputs and inputs, pricing, and lastly, phasing of development. And the results of sensitivity analysis, testing, and changes, which we will study, inshallah, into the phase two of this. Changes in assumption are reviewed. The adequacy of project financing and any risks it presents are also assessed. The second point, the analytical methods. The recommended analytical methods for appraisal are generally discounted cash flow techniques, which take into account the time value of money. People generally prefer to receive benefits as early as possible. This is very natural, while paying costs as late as possible. Costs and benefits occur at different points in the time in the life of the project, so the valuation of costs and benefits must take into account the time at which they occur. This concept of time preference is fundamental to proper appraisal, and so it is necessary to calculate the present values of all costs and benefits. So going next, NPV method. In the NPV method, the revenues and costs of the project are estimated and then are discounted and compared with the initial investment. The preferred option is the one with the highest positive NPV. Projects with the negative NPVs should be rejected because the present value of the stream of benefits is insufficient to recover the cost of the project. Compared to the other investment appraisal, next point, techniques such as IRR and the discounted payback period, the NPV is viewed as the most reliable technique to support investment appraisal decisions. There are some disadvantages with the NPV approach. If there are several independent and mutually exclusive projects, the NPV method will rank projects in order of descending NPV values. However, a smaller project with a low NPV may be more attractive due to higher ratio of discounted benefits to cost, particularly if there are affordability constraints. So NPV is basically gauge the project in the monetary terms. It basically gauge the project in monetary terms and give the weight of the project. Yes, and the BC ratio you will see in the coming presentation. It gives you a ratio, gives you if you invest $1, how much you will gain by investing a single dollar, and if it NPV gives you a value in totality. If you have invested into a project, what would be its final value? 50 million, what you will gain would be 60 million, 70 million, 80 million. That's the basically thing this presentation is trying to explain in its point two. So NPV method, further going on, using different evaluation techniques for the same basic data may yield conflicting conclusions. In choosing between option A and B, the NPV method may suggest that option A is preferable, while the IRR method may suggest that option B is preferable. Yes, it can happen. However, in such cases, the results indicated by the NPV methods are more reliable. The NPV method should always be used where money values over time need to be appraised. Nevertheless, the other techniques also yield useful additional information and may be worth using. So you cannot ignore the, in totality, the NPV, IRR, and BC ratio must be seen and not individually. That it is this presentation trying to explain. So discount rate, very important, very important. The discount rate is a concept because it will be used in all three methods: the NPV, the IRR, and the BC ratio. The discount rate is a concept related to the NPV method. The discount rate is used to convert costs and benefits to present value. PV is the present value to reflect the principle of time preference. The calculation of the discount rate can be based on a number of approaches, including, among others, following: the social rate of time preference, the way society values present as opposed to future consumption. Very natural. The opportunity cost, the third point, the opportunity cost of capital, the value of next highest value alternative use of capital. Yes, weighted average method, weighted average of different rates reflecting proportions of funds obtained from their respective sources. So we will study it basically when we'll go to the Excel data sheet. So the current recommended discount rate is like 17%. You can basically check it at your federal bank site. Like in America, it's the federal bank. In Pakistan, it's basically State Bank of Pakistan. Similarly, Indian Bank, Indian State Bank. So and different federal banks at different countries. So you can basically check your discount rate on the website of your respective federal bank or the state bank. So coming next, time value of money. It's very important. Basically, all these ideas are based on this time value of money, and it's very, very important. It's very natural, very natural. The idea that money available at the present time is worth more than the same amount in the future due to its potential earning capacity. The core principle of financial finance holds that provided money can earn interest, any amount of money is worth more the sooner it is received. The first four lines I would like to explain very simply. Like you have $1 in your hand now, and you can purchase so many things with $1 now. But in future, after 1 year, it's like with $1, maybe you can purchase four eggs, three eggs, five eggs, and in future, after 1 year, it will reduce. With $1, you will be able to purchase two eggs. See, similarly, if you invest in a project, the investment you would make right now would cost you $1 million, $2 million, but in future, after 1 year, it will cost you most probably the double. You will purchase those capital or those commodities or that labor at the double cost, or at least 10% or 20% inflated rates. And the second thing is the core principle of finance hold, the last four lines, the core principle of finance hold that provided money can earn interest, the amount of money is worth more sooner it is received. So because of interest, like if 10% you are gaining the interest rate is 22%, for example, per year. If you invested a money in some project, you would like to get the investment, the rate, the money over the principal rate much sooner, the much better. Otherwise, you are getting it by investing it into the bank. The 22% is already there, which you are getting after 1 year. So you want to get 22% most probably in 1 month on that money, or in 2 months 22% rather than in a year. So that's the main core principle. These two core principles are there in this statement. So going next, so this is the NPV formula. Net present value is the cash flow divided by parenthesis, bracket starts 1 plus I raised to the power n. See, where I is the discount rate, see, Y is the discount rate, N is the number, period number. So we will discuss it in the Excel sheet. So moving to the Excel, so this is basically the NPV. So I would like to first to show you the capital cost. This is the capital cost. This is the O&M cost. These are the cost, and this is the total cost. But please do remember that this capital cost here, this capital cost is the summary, between a column A and B. There could have been 20, 30, 40 or 50 columns. From those columns, this cost has been generated, this capital cost. There could have been machinery, there could have been labor, there could have been equipment cost. So there have been so many costs which have basically accumulated to this capital cost. So please, for your ease of view, I have basically reduced this sheet into these 1, 2, 3, 4, 5, 6, 7 columns. Otherwise, this sheet could have been like 70, 80 or 100 columns at the right side. See, and you see, similarly, while going, this is horizontal, while going on the vertical side, this sheet could have go to the 20 years. The project could have been for 25 years, 30 years. So we can go downwards too. So this sheet is a summary. Think of it as a summary, especially when you talk about the cost and the benefit. Especially if you don't want to talk about the years, so project can be of 10 years. Don't go for 25 years. But the capital cost cannot come up like this. It's a summary of the cost, which is basically somewhat hidden between A and B. It can't be 30 or 40 columns. So remember this. So when we talk about, we say 20 million capital cost during 1 year, so it's basically accumulation of so many costs. Similarly, you can sit with your engineers, so the person who are basically working on the project manager, you can sit with him or her, and you can basically come up with this column, with the capital cost, the summary column. Similarly, the O&M cost we started in year 4. First, second, and third year, you have basically invested in the project and the project has started, and from the fourth year, the O&M cost basically started incurring on the project. So again, the O&M cost is again the basically the accumulation of the columns. So between B and C, suppose there are 30 columns of O&M. Similarly, capital, machinery, equipment, labor, because for the O&M, operation and maintenance of say a road project, you need so many things. You need material, you need labor, you need machinery. So that is why this O&M cost is a summary of so many costs. So when you talk about the O&M 38.5 million, that means it's a summary of costs. See, or it's a beverage project. So initially, it's a cola project. So initially, the capital cost is like 60 million, and then you started investing on its operation and maintenance, the cola company. So that is like 38.5 million. Finally, the total cost, it can equally be applied on roads project, on building projects, on corporate projects, on public sector projects. So sky is the limit. It's about you, how you generate your story. I have generated my story, your story would be different, but the tools would be the same. So total cost, it's simply, you can see it's a summary. Again, I've used a formula of sum, function of sum B2 C2. So a total cost is 98.5 million, what your boss said, that I have 98.5 million to invest. So now the tool collected is basically again suppose that this is the final revenue collection. I have mentioned it tool collected because I was thinking of a road project, but now I am telling you about the corporate project. So rather than tool collected, you can write it the revenue collected. I will write it. It's to clear you, revenue collected. See, so revenue collected is 245 million, but it started from the fifth year. So 245 million, and incremental net benefits is basically simply benefits, the revenue minus the cost. Benefits minus the cost. Here, revenue are the benefits, and this is the total cost. So E2, here you can see that E2 minus D2, E2 minus D2. So this is the final outcome. For the first 3 years, it's minus 20, 20, 20. Again, I have used conditional formatting here. The conditional formatting, you can basically, I have my lessons in the playlist, so you can check conditional formatting from there. So with minus 20 automatically becomes red. Minus sign, it automatically becomes red. So 16 million again, 20, 25 million, 25, 20.5, 25 million, 29.5 million. Again, the final outcome is 146.5 million. See the final benefit. And you see, similarly, now this is the final function. I would show you the cash flow. See, the formula here is F2, the cash F2, 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 the cash flow is basically coming into this formula, F2 divided by 1 plus $G $13. This is the discount rate, G13. See, G13, G13. So this is the discount rate, and I have again applied what? The static cell. The static cell is in my lesson 8. I have already told you about the static cell. So I have not repeated it again and again. I have not repeated discount rate here. Only by mentioning it here, I have multiplied it with so many cells. So 1 plus $G plus added it, sorry, not multiply bit. 1 plus $G $13 raised to the power. This is raised to the power A2. A2 is what? A2, this is the year, with the year. What? Period number. Say, in this period number, discounted the period number. So we have basically converted this formula into a function. This is the function. So this formula into this function. So NPV formula has been transferred into a function. The raised to the power is very simple. Like you write 2 here is equal to 2 here, and then shift 6, press 6. This basically reverse cap, the cap sign, and press like 36, press 12. So press enter. See, 4096. So this is raised to the power formula. Remember it. So by multiplying it, by applying it, I have drag it down. and the final outcome, the NPV is basically what? 21.27 million. 20 at 17% discount rate, the NPV final is basically 21.27 million. So you have come up with one thing. The NPV is what? Positive. It's not negative. It's positive. By investing 98.5 million, you are getting the NPV in 10 years 21.27 million. So that's the one result you have come up with. Then I will go to the next. This is internal rate of return. The internal rate of return is a discount rate when applied to cash flow of a project sets them equal to initial investment, like NPV will become zero. That discount rate at which the net present value becomes zero is basically your internal rate of return. The preferred option is one with the IRR most in excess of specified rate of return, and IRR of 10% means with a discount rate of 10% the project breaks even here. So come on the IRR. See that IRR is 26.5657%. Yeah, this is the Excel IRR formula is equal to IRR seen formula bar is equal to IRR F2 into F11. See, this is the incremental net benefits which I have already shown in the NPV. It's the same sheet which I have already incremental net benefits 146.5 simply by minusing the revenue, the cost from the revenues. So subtracting the cost from the revenues, 146.5 million in IRR, it's coming 146.5 million the total value, and this IRR you can see that the formula, the function is F2, the complete, and 17% discount rate you have applied here. It asks automatically what would be the discount rate you would like to apply. So 26.57%, see the 26.57%, this NPV become zero. So in other terms, you can say that this project in 10 years is giving the internal rate of return or the rate of return of 26.57%. So by investing into this project, you will get 26.57% rate of return. So yes, in case of public projects, third number, in case of public project, the hurdle rate is the discount rate. The second point, I am sorry, I forgot about it. The IRR approach is usually associated with a hurdle cost of capital discount rate against the IRR is compared. The hurdle rate corresponds to the opportunity cost of the capital. Yes, opportunity cost, if you invest it somewhere else, what could you have get? So it is basically comparison between the interest rate and the IRR. Well, again, the way your boss said initially that if I invest it into the bank or invest into this project, what you would suggest. So this is that. In case of public projects, the hurdle rate is discount rate. If the IRR exceeds the hurdle rate, the project is accepted. So in this case, the hurdle rate was 17%. You can see that, and the IRR is 26.57%. So it seems appropriate. There are disadvantages associated. Fourth point, there are disadvantages associated with IRR as a performance indicator. It is not suitable for the ranking of competing projects. Again, if there are 2 or 3 projects, it would not be appropriate for the competition alone. Yes, but in totality, it is possible for 2 projects to have the same IRR but different NPVs due to differences in timing or when those costs and benefits occur. In addition, applying different appraisal techniques to the same basic data may yield contradictory conclusions. Moreover, the IRR technique is only suitable for projects that are supposed to yield some revenues and cash inflows. So IRR must be applied on the projects, not only the social projects, but the projects having economic benefits. Yes. And coming to the next, this is the benefit cost ratio. The BC benefit cost ratio, that is the discounted net revenue divided by the initial investment. The preferred option is the one with the ratio most in excess of 1. So we would come to the BC Excel sheet again. I have opened the Excel sheet. So you can see that till tool collected 245 million tool collected. We are here, and again PV of benefit, the present value of benefits, we have calculated it, and the PV of the benefits is becoming has become 78.18 million. Till here we have simply applied the basically net present value function, and on that and on the top of it, what we have done is G2 divided by E2. G2, see, net benefits, net present value of benefits 78.18 divided by what? E2, the PV of cost, the PV of benefits divided by the PV of cost. See, so this is the main game behind this formula. You can see the functions here. See, we have first D3. We have basically D3 discounted. We have basically present value of cost. We find the present value of cost, and then we find the present value of benefits. We have found the both. In IRR, we were basically only concentrating on the present value of benefits. We were not basically doing the present value of cost. In NPV, again, we were basically concentrating on the present value of benefits. But in BCR, we are concentrating on both the present value of cost, similarly the present value of benefits, and the total, the final, we divide the present value of benefits with the present value of cost. That's the main difference between the two, the IRR and the NPV and the BC. So the final outcome is, by dividing the present value of benefits by with the present value of cost, the final outcome is 1.37. Here's the formula. In the formula bar, you can see that. So this is good. It's more than 1. So the definition, we are defining it that it should be in excess. So you can simply say, by investing $1, you are getting 37 cents. So it's not a bad thing. Anything which is going beyond 1, it's good. So in any event, a project with a BCR of less than 1 should generally not proceed it. See, so if it's less than 1, that means that by investing $1, you are getting, if it was giving like 0.98, 0.98 or 0.90, that means by investing 1, you are getting 98 cents or 90 cents. So that would not be appropriate. Even with your principal amount, you are getting less than your principal amount. So that would not be appropriate or suggestible. The advantage of this method is its simplicity. Using the BCR alone to rank project can lead to suboptimal decision, as a project with a slightly higher BCR ratio will be selected over a project with a lower BCR, even though the later project has the capacity to generate much greater economic benefit because it has a higher NPV value and involves greater scale. So again and again, we are concentrating on that all the three values of BCR, the NPV and the IRR, they basically in accumulation, they give you a total picture. So you see all the three, and you see also the project benefits, and then you can make a conclusive decision. Otherwise, they may dodge you. They should not be seen in the silos. So this is the end of my session, and kindly do check the part 2 of it, because I have basically responded to the first part of my boss question, and I've given him these 3 figures, and now he's more concerned about the fluctuations and the sensitivity analysis. So it will be covered in part 2. Well, thank you very much for watching my session, and I would request you to kindly like it, subscribe it, subscribe my channel, and share it if you find value in it. And please do take good care of yourself, and Allah Hafiz.